So let's scroll through the Java API and explore the contents a little bit more. So you can see there's some examples of how to use the string library or how to use strings in your program down here. Let's scroll down to where it says, here's some more examples. So you see that there's 5 lines of code here, and then it walks us through a little explanation of what each of them does. So let's check out the first one. Whenever we say system.out.println and then include a string literal like ABC, remember, a literal just means the actual value. We've like hard coded that value into our program. It's not going to change. It's not a variable. It's just a value that doesn't change at all during the lifetime of the program. So if we say system.out.println and then include the string ABC, then in Java, that's going to print out the value ABC. Let's test that out in IntelliJ. I'm going to type it in there to try it out. You can see when I run it, it's going to print the letters A, B, C. Let's look at the next example. It says, let's create a string called CDE. So it's the name of my string object. And then it's telling us we want to include the actual characters C, D, and E as the contents of that variable. If you check out your class notes, I drew a little diagram of how the memory looks in Java. So anytime you're making an object, it makes like a collection of storage. I always draw that like it's a big oval, because we're not just storing one data value here. We're going to store multiple data values bundled together. Then up at the top, I listed the name or identifier of this particular variable, and its name is CDE. We know that because in the example, it said that the string's name was CDE. And then finally, I'm going to store the contents indicated to the right of the assignment operator into the memory locations inside this variable. So anytime we're making a string, it's making this collection of characters that are adjacent to each other. It's storing one character in each of these adjacent memory cells. So the second line of code, it doesn't print anything out to the screen, it's just storing information in memory. And we'll be able to see that if we go to our IntelliJ editor and add this line of code into our example. If we say, I want to make a new string object, CDE, and store the content CDE. When I run the program, it's not going to change anything about the output. It's still going to print our ABC. But now we've created the storage behind the scenes in the computer's memory, so it's storing those additional characters. Let's look at the next example. So the next one says, I want to print out the string literal ABC, and I'm going to concatenate to that the contents of my variable CDE. I can tell that the ABC is a string literal because it has double quotes around it. I can tell that the identifier CDE is a name because it does not have double quotes around it. It's a sequence of characters, so that is a variable identifier. So in this case, if we type that into our IntelliJ file, it's going to print out some additional information. So system.out.println, and I want to print the characters ABC and then concatenate to that the contents of the variable CDE. I'm going to run it to update it. So you can see that my second print statement printed out that first sequence of characters ABC and then printed out the contents of my variable CDE. Now it's a little bit hard to tell that it's printing the contents of CDE and not the name of the variable since they happen to be identical. Let's change this up so it's 3 A's instead, and then you'll be able to see clearly that it is printing the contents of the variable CDE, not the identifier for that variable. There's some additional example method calls in here. We're not going to worry about those right now, but maybe we'll revisit them later in a future class period. Let's continue scrolling on the API page. We scroll down a little bit, eventually we'll get to a section that's called Method Summary. This is a list of all the different methods that are available to us that we could use with a string data type. It gives us information about the method itself through the method signature. Each of these lines in the listing represents one method signature. Remember that each method signature contains 3 pieces of information: the name of the method, That's included right under the label that says method. Also includes information about the parameter list. That's the information that our method expects to receive. And then finally, it has information about the return type for this method. That's over on the left-hand side. That's information that'll be returned from our method. In addition to the method signature, each of these lines also includes a description of the method, which helps you understand when you might want to use that in your own code. You probably remember using methods in your previous programming course. Remember that a method's kind of like a black box, and as a programmer, you don't need to understand all of the interworkings. So for example, you don't necessarily need to know how to write the code to accomplish the method char at, but because you understand how to call that particular method, you're able to operate that function and get the desired result from your program. So you can learn everything that you need to know about how the method operates from the method signature, and that empowers you to utilize that function or that method in your own code. So let's look at an example of how we could use some of these methods that are part of the string class. In order to call one of the methods in the string class, we have to create an object of the string class. In other words, a variable that has the data type string. Here's an example of what that would look like in Java. We'd put in the name of the class, which is string. It's my data type. Then we'd include the identifier for the object. So I'm calling my name. Then we can use the assignment operator, and we can assign a value to that particular object. I'm assigning the value Karen, because that's my first name. In this example, we're creating a bundle of information. So remember, I always draw that like a big oval. And then we're including a list of characters in individual boxes, one box for each of the characters in the string. One for the capital K, one for the lowercase a, one for the R, one for the E, and one for the N. Now, if we're going to call one of the methods on our object, we can use one of these two general formats. We'll either include the object name and then a period, then the method name with the arguments that we need inside parentheses right afterwards, and then always wrap it up with a semicolon. Or if the method includes a return type, we'll use the second version of the method call. It looks exactly the same. So it's still the object name, a period, then the method name with the arguments in parentheses and a semicolon at the end. But because we know that this method returns a value, we have to capture that information coming back from the method in a variable. So I'm calling it by saying result equals, and then the name of and then the method call itself. Now you might be wondering to yourself, what do we mean by the term argument? An argument is the actual value that is passed into a method. So the method itself is set up to include a parameter, which is kind of like a generic placeholder name that's utilized inside the method's instructions. And we don't really care about that because we're not trying to see inside the black box. We're just trying to use the black box. So we don't need to know what the parameter's name is. We just need to know what it represents. And then we need to pass in our actual data value, the information from our program that the method should utilize. And that's the argument. An argument can be a literal value or a variable. We're going to look at some examples, but before we do, remember that we're going to use version 1 of the method call syntax when the method does not return a value. And we're going to use version 2 when the method does return a value.